Hello everyone, this is Team Coders and I'll be explaining the working demo of a prototype. So what we first did here is we used API to collect the weather data and the traffic data, and then we merged the data and we stored it into a CSV file. And after displaying the basic start of our merged data, we noticed that there are missing values and there were outliers as well. So we need to handle it. So we clean the data before using it for further analysis and modeling. Let me show you the missing values and the outliers. Just a sec, it's running. Yeah, so here we can clearly see that there are missing values. So we need to handle it as it should have been 155. And by visualizing the box plot, we can clearly see that there's outliers, so we need to handle it. And even in the histogram, this lower peak might indicate a potential outlier, so we need to handle the outliers. So we clean the data before using it for further analysis. And here we split our clean merge data into training and testing set. And we use gradient boosting to build a predictive model, and then we trained it, and then we used it to make predict and then we tested it, and we noticed that it is predicting the speed pretty accurately. Let me show you the graph. The performance of the model was pretty good. Yeah, so this is the pair of predicted speed and the actual speed, and this red line is the line of prediction. This is the line where the predicted speed and actual speed are equal, and the more close these blue dots are to this line of prediction, the better our model is predicting the speed. So we can clearly see that the performance of a model is pretty good. So it's predicting the speed pretty accurately. So this is the route segments. We'll be traveling from 0 to 1, 1 to 2, and 2 to 3. So a model will be predicting the speed for each route segments for these traffic conditions. For example, 70 is the free flow speed, 25 is the temperature, and all that features. So we'll be giving the input to the these are the inputs we'll be giving to the prediction model, and these are the traffic conditions for which we are predicting the speed. So for each route segment, the traffic speed will be predicted, and based on the predicted speed, the travel cost will be calculated. Higher the speed, less will be travel cost, and we'll store it in the predicted traffic. So for each route segments, the travel cost will be stored, and later the predicted traffic will be used to solve the vehicle routing problem. So for solving the vehicle routing problem, this is the base distance matrix that we are considering. This is the distance matrix without considering any real-time traffic condition. And then the distance matrix is adjusted based on the predicted traffic. And then the vehicle routing problem uses the adjusted distance matrix to compute the travel cost for a predefined route. Let me show you the output. So we can see that the traffic adjustment has led to significant reduction in the cost. This is the base cost and this is the adjusted cost. And we can see that the cost is reduced by approx 75%. This is the total cost that it took us to travel a predefined route. So what it's telling us, if this is the predefined route and these are the traffic prediction, then to travel this route, if these are the traffic prediction on that particular day, if you travel by this route, then our cost will be reduced by 75%. Let me repeat it. If we are traveling by this route and these are the traffic prediction on a particular day, then traveling by this route will reduce our travel cost by 75%. That's what our model is telling us, and that's how we can minimize our travel cost. So this was the working demo of our prototype. Thank you.